I'm gonna go in here and say, well, for block 1, the only force that is important here would be the tension, and that's actually what they're asking for, so I'm going to put a question mark. The mass 1 we have given, and the acceleration is also what they're asking for. For block 2, they are asking for the tension. We have the weight given. Remember, I didn't put a check mark over here for block 1 because that weight here is cancelled by the normal force anyway and being perpendicular to the direction of motion. Back to block 2, the mass 2 is given, 19.0 kilograms, and the acceleration is what is being asked for. Okay, so let's write down Newton's second law, which is the tension 1 equals mass 1 times acceleration, and for block 2 the tension 2 plus the weight of block 2 equals mass times, equals mass 2 times acceleration. Okay, at that point I may want to be careful, or I already have to be careful. Let's look at the tension here. The tension here is pointing to the right, so that's positive. The mass here, of course, is a positive number, and the acceleration therefore also comes out positive, and that makes sense because the block is being pulled to the right. For block 2, the tension here is positive, the weight is negative, and it should be larger than the tension because otherwise that thing wouldn't fall down or wouldn't be accelerated down, and therefore that acceleration would need to be negative. Okay, here's one of the problems. This acceleration and this acceleration numerically are the same number because the two are connected, so both are accelerated with the same amount, whatever that is. I just make something up, 3 meters per second squared. So both are accelerated, but this one here is positive because it goes to the right. This one here is negative because it goes down. So this here doesn't naturally pop out of the equation, but I actually have to put that in. I have to say that whatever acceleration I'm going to come up with would have to be overall negative, but the A itself here has to be positive because it is over here. Otherwise I have two different A's. I have a positive one here and I would have a negative one here. Now I have a positive one here, still a positive one here, but there's that negative that I need in order to make these two equations go together. As I said, it still has to do with the pulley. I'm going to get to the pulley in probably a few minutes here. Okay, let's look at the tensions. Well, there is tension 1, and then there is tension 2. And as you can see, or as you should see, these two are actually equal and opposite forces because that block here is being pulled by the other block, and this block here is being pulled by the first block. So those two tensions actually come out to be the same. And if you look at the numbers here, that tension is positive and that tension is positive, so T1 equals T2. That will help us in the derivation, but there is a problem because Newton's third law, action and reaction, equal and opposite forces on two different objects, says that they have to be opposite, so there should be actually a minus. So here is actually a minus missing. As I said, for the algebra it helps us, but it's not totally consistent with Newton's third law. Well, what happened? Well, they were not even in opposite directions because this one is pointing right and this one is pointing up. Well, it's the pulley's fault. The pulley is redirecting the forces, and so the rope being strung over the pulley actually exerts a force, a tension on the pulley. So actually this one here is the proper equal and opposite force of tension 1, and this one here is the proper equal and opposite force to tension 2, which means that these two here could be considered components, which means that overall there is a net force. Now, we're not interested in that net force here on the pulley. We're not interested in the pulley, but I need to draw it in here to show what's going on. So these two components together, this one here and this one together, make this net force here, that where the rope is pushing on the pulley, pushing it into the corner of the table, where then again there is another equal and opposite force from the table pushing back on the pulley, otherwise that pulley would break off. So it gets a little bit interesting here, drawing these equal and opposite forces in order to make it consistent. But basically what the pulley is doing is it's redirecting the tensions, and therefore Newton's third law looks a little bit strange, where it says T1 equals T2 with that minus missing there. But the reason is that the rope is being pulled over the pulley. Imagine if you took this entire block and you put it horizontal, and now you pulled it in the horizontal. Well, then T2 would be pointing to the left, and truly would be equal and opposite to T1. And I keep repeating myself, it's the pulley's fault that is redirecting those tensions, and therefore introducing a kind of strange looking Newton's third law. Anyway, for the algebra, actually it helps to just say T1 equals T2, because now what I'm going to do is I'm going to plug in here M1 times A on the left hand side, and on the right hand side I'm going to plug in negative M2 times A minus W2. You can see that at the bottom here. So I just solve for T2. That negative here, A, well, that whole thing is negative acceleration, but the A itself is still a positive number, just like this one here, and that's good, because this one here should be the same number as this. And then the weight itself is negative over here. By putting it to the other side, I'm actually subtracting a negative number. So now for coming up with something for the acceleration on the left here, and I'm going to say M1 plus M2 times A equals negative weight 2. So, and then I'm going to come up here with acceleration equals negative weight 2 divided by the two masses added together. And when you look at that, you come up with a positive number, because this is a negative of a negative. Come up with a positive number. Why is that different from, or why is that the only difference to the quick way we did earlier? Well, because earlier I just looked at the acceleration of this block being pulled down, it comes out negative, and here I'm looking at the acceleration as an absolute value, so it's the acceleration being pulled to the right for this one here, so it's positive. And then here, if I want to know it for block 2, I put a negative in front of it, making that acceleration to be negative. Lastly, computing the tension then is just one more step, and that would be, for example, T1 equals mass 1 times acceleration once I have computed that, and over here I compute the acceleration as positive, and so that will also come out with a positive number. That makes sense because the tension is pointing to the right.